Hello and welcome to the latest roundtable discussion from GIE Media's manufacturing group as we discuss testing, measurement, and inspection. I'm Jake Kaufman, a managing editor for GIE, and the panelists are standing by waiting to answer questions about testing, measurement, and inspection tools evolving to meet the challenges that manufacturers face today. However, first, we would like to thank today's sponsors, Starrett and Wenzel. The L.S. Starrett Company, founded in 1880, is a leading global manufacturer of a range of metrology solutions, including video measurement and inspection systems, multi-sensor vision systems, optical comparators, and force measurement and material testing systems, as well as custom metrology solutions, hundreds of precision measuring tools and gauges, and more. The Starrett Metrology Department employs an integrated approach to vision and optical technology, driven by application and dedicated to maximizing customer accuracy and throughput. Engineers and highly trained technicians design and build solutions for demanding requirements. And Wenzel is a family-owned business started in 1968 by Here Werner Wenzel. The manufacturer world-class measuring systems and metrology technology used throughout the manufacturing industry, built on a solid foundation of family, German precision engineering, flexibility, and strong partnerships. Their metrology systems are trusted to offer quality solutions. Wenzel is a world leader in manufacturing of coordinate measuring machines, gear inspection, and computed tomography to drive productivity and efficiency through the manufacturing process. Their software also provides powerful solutions for optimal use of metrology systems. Wenzel America, located in Wixom, Michigan, has been serving North America for more than 20 years, delivering on Here Werner Wenzel's promise. And we are also joined today by Verisurf Software Inc. They are a measurement solutions company focused on accelerating measurement and processes for precision inspection, product assembly, and reverse engineering. Their experts keep manufacturers ahead of rapidly changing technology through the implementation of 3D measurement solutions with comprehensive installation and support services, delivering maximum return on investment. Now, before we get to today's discussion, let's get to know the panel a little better. Greg Maisch has been with Starrett for 7 years, where he serves as an engineering manager. He leads the design and development of vision-focused multi-axis metrology systems in Laguna Hills, California. He has a bachelor's degree in mechanical engineering from Cal State Fullerton, and also was previously enlisted as a Marine. Drew Shemensky is the president of Wenzel America Limited, with 20 years of experience in the quality and metrology fields. After several years as a quality engineer working in the automotive sector, Drew started his journey in metrology in 2001, focused on software and metrology applications. Over the years, he has held various management and sales positions, leading him to Wenzel America in 2014 as a sales manager. And in 2016, Drew became the president of Wenzel America, leading the company through a period of strong growth in a changing industry landscape. And David Olson is a global sales and marketing director at Verisurf Software Inc. Olson started working as a mechanical engineer at General Dynamics in 1984 after graduating from San Diego State University with a bachelor's of science in mechanical engineering with a specialization in virtual and physical simulation. He then graduated with a master's degree in technology marketing from the George Washington University. He has been the director of sales and marketing at Verisurf Software since 2009. Now, we will be joined right now by the panelists as they will get right to the discussion. And first up, we have Greg over at Starrett, as I will ask you this question, Greg. What new technology provides the best bang for your buck in terms of efficiency in quality control?
Thanks, Jake. Happy to be here. So yeah, I think, and of course, this is just from my experience. I think as far as bang for your buck goes, finding a machine that's capable of automated inspection, that's appropriate for your application is going to be the best bang for the buck in terms of efficiency, right? Anytime that you're able to eliminate somebody sitting there with a caliper doing all these different measurements manually and automate that into some sort of CNC controlled device, it's going to be hugely impactful as far as your throughput goes, be that offline or online. Um, so I think, that's probably the best bang for your buck. I think if you have a multi-sensor system, you will have more flexibility, which means that you have more ability to measure different types of parts that may or may not be important depending on your application. But yeah, I think that those are really the things to consider there. And that, obviously a lot of that stuff has been around for a while. I think that I'm really curious to see when it comes to new stuff, how the advancements when it comes to AI are going to affect the data processing when it comes to the output of those systems, right? So now that you've got these huge amounts of data, there has been machine learning around for a long time, but we're at a point now where not only can it tell you, is this thing, is it good or bad? And it's doing machine learning in that sense, but can it actually intuit other things about your part that previously were not, possible, and may not even be possible for humans themselves to do, looking at these huge data sets. So I don't think we're quite there yet for that. But obviously that kind of solution is sort of infinitely scalable. So I think that in the next few years, that's going to be playing a large role when it comes to analyzing the results of these types of inspection. So, I don't think that probably that is there yet, but I think that's going to be a huge bang for your buck in the future.
Awesome.
Yeah.
Perfect. Well, thank you, Greg. Drew, we will go to you with the same question. What kind of new technology is providing the best bang for your buck in terms of efficiency for quality control?
I think what we see with our customers, particularly in the job shop segment and the smaller companies, the ability to get into 5-axis probing for a relatively low cost gives you a tremendous amount of flexibility. A lot of these companies have a variety of different parts, and a lot of these, our customers in this segment will have Starrett systems. And we know where those systems leave off, even if they're a multi-sensor, there's some part configurations that maybe are too large or a different complexity. And that's where the CMM comes in, the tactile CMM. And with a 5-axis probe head, it gives you so much capability to adapt to maybe your mix changing on a daily basis, and to be able to quickly change over parts, reduce your tooling costs, reduce your setup time, and make it a little less intimidating also for less experienced staff to take the technology on and to really take an advantage of it.
Awesome. Thank you, Drew. So we wrap up this round of questions with David over at Verisurf. So same question to you then, David. What new technology is providing the best bang for your buck as far as efficiency in quality control?
Yeah. This is really fun. Thank you for having Verisurf for myself. You're going to find a lot of interesting alternatives here. A lot of our customers, need a transition when going from manual handheld tools, calipers, micrometers, height gauges, pin gauges, working on a surface plate, to a more programmed environment. And some of them just don't quite have the quantities. And so for us, we think there's a nice middle ground before going to full automation, and that would be a portable CMM. As far as bang for buck goes, I mean, you can get in these things for, $24,000 with software and training under $30,000. And you got accuracies about 25 micron, plus or minus 25 micron, or plus or minus a thou. Because it's still tactile, people that can measure parts by hand do very, very well with these probing devices. There are scanners available with these things as well. But the benefit is that you can also then get them into creating a program. For instance, you can create a repeatable program with a manual device where the computer display steps them through exactly how to align, where to touch the part, where to take the measurement, and then through every step of measuring every feature or every profile. And then the product, if it's programmed, will create perpendicularities and other constructions and create an once all the measurements are made, it'll automatically create a report. So I think there's a middle ground before you go to a full automation with portable or even manual CMMs can be automated. So bang for buck, that's a good starter. The people aren't scared about having to create a complex program up front.
Awesome. Thank you, David. So we'll go back to Drew at Wenzel with the next question. And when it does come to quality control solutions, are they more affordable now compared to something that might have been impractical for small businesses just a few years ago?
Yeah, we've seen a big shift in the last 10 years in the product ranges. And the most impactful thing, I think, is the increase in accuracy available to people at certain price points. So, we have micron and submicron machines available now under $100,000 at times. And it just gives a level of uncertainty management to shops that maybe couldn't afford that 10 or 15 years ago and had assumed that all we can afford is maybe a portable machine or maybe a used machine that's, 5 or 10 years old, things like that. So that cutting edge for us as a manufacturer, we're always trying to push that. How do we get more accuracy out of our systems for a long period of time? The durability of the machines as well is always increasing. So, being able to make an investment now at that high accuracy and keep it running effectively with a low cost of ownership for 10 or 15 or 20 years, that's really where a lot of the value comes in now.
Awesome. Thank you, Drew. So David, we'll go back to you at Verisurf with the same question. As far as the quality control solutions, how are they kind of more affordable now compared to things that might have been impractical before for small businesses?
Yeah, really good question. So I would say about half of our customers are small to medium-sized business shops, machine shops, whether they're doing machining or they're doing, sheet metal, stamping, folding, or plastic injection molding or die casting. These places are looking for something that's practical, easy, and trainable. And for us, again, my answer is going to be, these portable CMMs, if the quantities of measurements or the number of parts you have to do in a certain time frame are acceptable. And also the accuracies of the portable CMM. Again, I'll go back to plus or minus 25 micron or plus or minus 1 thou. And you're doing batches of 5, 6, 10 maybe. Once you start getting over batches larger or you need higher accuracy, then you're going to need the more automated machines that you'd find with Starrett or Wenzel. So yeah, bang for buck for small to medium sizes. Again, I would probably be leaning toward portables, depending on volume and accuracy.
Awesome. Thank you, David. So Greg, we'll switch it over to you to wrap up this round of questions. As far as quality control solutions, what are you kind of seeing in the affordability spectrum as far as what used to be kind of impractical for small businesses?
Let's see. Well, sort of as Drew, was pointing to, is that these things, as the years go by, they become more and more affordable, right? So, and we really do sell to a lot of small shops now. I mean, even our, highly automated, we're getting down to single digit micron accuracy machines. Folks at, smaller machine shops are buying these things. And, and really that has to do with the electronics themselves, at least in our case, becoming more affordable. The encoders, the sensors, even the profile lights, all that stuff becomes more and more affordable. Like that really gets more affordable quickly. The big hardware, the granite gantries, that kind of stuff, that's always going to cost a certain amount of money to make, right? But as the sensors and the processing gets better and the ability to synthesize that data, output reports, all that kind of stuff. So I think it's really that you get more for the same price as what you used to get, hugely. In our particular world, because we're largely vision based, what we see is that there'll be big jumps in the ability to get accuracy with large fields of view as the sensors become more affordable. So, for a while there, it was like 5 megapixel cameras were just, unaffordable for most designs. And then all of a sudden it's like now they're not expensive anymore. Everybody can have that. Now we're getting to that with 12 megapixel industrial cameras. And I think really 20 megapixel is starting to happen too. So as that continues to improve, you can have a larger field of view with a higher resolution, and you can be imaging and measuring more features and faster. So, it's not that I would expect to see the price points to drop drastically for the machine. It's that the machine itself becomes drastically more capable over time. And and also the software becomes more approachable, and more integrated into the rest of your shop. So, for all those reasons, it's like it just becomes more attractive overall for people who maybe it was too narrow of a use case before. Now there's just a lot more stuff you can do for the money that you're spending, and it's easier to learn it.
Awesome. Thank you, Greg. So speaking of learning, we go to that next subject with David over at Verisurf. So small businesses, they obviously have a lot of tribal knowledge when it comes to the parts that they inspect, but how can you build a process that allows for consistent inspections regardless of the person who is doing that inspection? Like, how do you, with training new operators and things like that, how is the tribal knowledge and metrology kind of working together?
Mm-hmm. Yeah, I think that almost everyone will admit that training is key, to create the next generation of metrologists. In that regard, Verisurf discounts our software products 95%. So it's not exactly free because there's some administrative cost and support costs associated with supporting instructors and teachers, but you'll find our product in, from middle school, high school level, all the way through junior colleges have the greatest adoption because they tend to be more into the trades, and also universities. So training is important for us, so much so that we not only provide our software to universities at a big discount, but we also provide our software to any student who wants to learn for free. So we have the Verisurf Learning Edition. It is absolutely free. Anybody can go down, install it, load it, and run hundreds of different measuring devices. So there's still the problem. Hey, I need to get just over the hump to learn the basics. Well, we also provide online video training for free. So anyone can go on to Verisurf Trainer Central and learn how to use our software, download our software for free, and use it. So I would dare say that we're probably the only metrology software company in the world that has all of this for free. So we take this train the next generation metrologists very seriously. With that said, there's still more for beating tribal knowledge or getting over tribal knowledge. And for us, it's the automation of manual CMMs. Like I said, a lot of small, medium-sized shops or low production shops, their first CMM is going to be a portable, because it's the transition from the surface plate, to a programmable CMM. It's that intermediate step. And when you can document every step of the way of how to align, inspect, and report in the software that steps the user through step by step, you do a great service in increasing repeatability, but also decreasing human uncertainty in the measurement process. So this is how we address tribal knowledge, both from a training and a product perspective.
Awesome. Thank you, David. So yep. Greg over at Starrett, we will go back to you with this question as well. When it does come time to essentially train new people, how is it easier to build a consistent process for the inspections and kind of overcome that tribal knowledge that seems to be built into metrology?
Yeah, obviously when we sell a system, we wind up in that situation basically every time, right? You go into a shop, they have their way of measuring their part, they hand you their part, you've got your machine, they want you to measure it, right? So they have expectations of how you're going to do that. And generally, because it's a different type of process than what they're used to doing, some of it is you want to use that tribal knowledge to build your program in a way that, aligns with what their goals are. At the same time, you also need to sort of break those expectations and tell them, hey, I know this is how you're used to doing this, but believe me, if we do it this way, it's going to be, much faster for you. And it's just more universal in general. You don't have to tell somebody to do this way. It will simply be, fixture your part this way, or, you know, align your program around these features, and you no longer have to worry about putting it on a small stage and skewing it perfectly to the camera skew like you would do on a comparator. The machine doesn't care about that. It's going to align its reference frame no matter where you put that on the stage. So I think, you know, it's a combination of working with the knowledge that they have, because a lot of times, obviously, they know their parts better than anybody, right? It's their parts. So you can't discount their knowledge when it comes to that. But, you know, showing them how you can sort of modularize the process and, you know, and really apply your product to their environment is key when it comes to automating it. And then once you have the program written, anybody can pull that program up and start the program, you know, align the part and measure it. If they buy a second machine, you can put that program on the second machine. It can be measuring, you know, within minutes. So that's really the way to sort of scale that in my experience.
Awesome. Thank you, Greg. So Drew over at Wenzel, we'll wrap things up with you for this round of questions. When it does come to using the tribal knowledge and also training new operators, kind of what is the line that you walk over at Wenzel as far as allowing consistent inspections, but also being able to train someone new?
Well, I think, you know, building on what Greg and David both said, you know, I love the point David made about removing obstacles to learning the tools. And, you know, Greg talked about providing good tools that allow them to automate and be consistent. But at the end of the day, you're changing someone's daily process. And so there's a cultural / emotional component to it too. And this is why we love to do on-site training versus generic classroom training, because, you know, our apps people get to then work with the person who is the process expert and the new person and help negotiate that and say, you know, we're not trying to replace anything here. We're trying to take everything you know about your process and put it in a framework that allows the rest of the team to provide the same consistent results time and time again, so that you can all be more productive. And you don't have to get phone calls at, you know, on second shift and things like that. No one wants that stuff. But when you start to remove it without context, you know, there's a management issue there. And so a lot of that is why we like to be on site and do the training, because we get to help not just the operators, but then also the people around to navigate that and get them to buy in and really see the value in the new tools being presented to them. At the end of the day, if the people don't want to use it, doesn't matter which software or machine they bought, it has a high chance of failure. So we have to get that buy-in there. It's critical.
Awesome. Thank you, Drew. So we'll go back to Greg Maisch at Starrett with our next question. Now, obviously, inspection can be difficult to automate, especially for the complex parts or parts that are difficult to quantify the criteria. So what are some ways that the process can be automated?
Right. So at least in our world, you know, there's sort of 3 levels of the automation. You know, the simplest being is if you have a machine that's simply measuring within the field of view, you can program it in a way that when you put your part in that field of view, it recognizes the part, pulls up the program based on the features that it's seeing, and runs the measurement, right? And you can program a part like that in 10 minutes. It's very simple to do it. That's sort of the first level. Obviously, you know, that only works if your entire part or the features that you're interested in fit within that field of view. As you sort of move up in complexity, you could then have a manual machine that we offer, where you could still recognize the part based on what it's seeing inside the field of view. However, it would then pull up the program and it will tell you where to drive to. So as you're measuring these features, everybody's doing it in the same order, right? It's not like, oh, I'm going to measure the right-hand side and then the hole over here, and then the other guy's doing it in the opposite order. It will literally instruct you where to go, and you can even add, you know, notes and things like that. So that is sort of the next level up as far as automation goes for us. And then at the highest level, obviously, is a fully automated CNC machine. Once you program that, you put the part down, it can recognize it, say, hey, we see this. Do you want us to run the inspection? You say yes. And at that point, you're basically done. So those are really and obviously, you know, as you move up in complexity, there's a little bit more training required, but from my experience, we're able to get people to that, you know, 3rd level within a day of training. So that's, you know, obviously they need to practice past that to really get become an expert at it, but it's you can get them off and running that quickly.
Awesome. Thank you, Greg. So Drew over at Wenzel, we'll go back to you with when it does come for complex parts and things like that. How easy is it or how difficult is it to automate that process?
Well, that depends. So the biggest growth area we see with our customers, though, is the availability of better data. So with smarter CAD models that contain embedded GD&T data and all the PMI type data that's available, there's now tools in the softwares to take this data out of the CAD model and automatically create this skeleton of the program, which gets you from, the old days of sitting down with a print at the CMM and the first part and driving around. And I'm even showing my age. I got 2 joysticks to drive with, and beeping the part to build the program, and spending days doing that, to you can have all your programs written for even multiple ops before the first part comes off the spindle, and you can test them offline. So using those tools that are available in the software to really take advantage of the process data that's available and then work in an offline situation so the machines can be running and making you money. That's really the key we see to the next level.
Awesome. Thank you, Drew. So David, will wrap up with you in this round of questions. When it does come to automation in metrology, what are some ways that can be done, even if you are using complex parts?
All right, I'm glad you still had some time for me on this one. Drew, I think nailed it pretty good. I mean, model-based definition, model associative intelligent, GD&T associated with the CAD model. It is the future. People, especially large OEMs, I mean, from the design team, all the way through the manufacturing process and setting up other process control within the manufacturing facility, model-based definition or product manufacturing information associated with the CAD model is driving on many processes, including inspection and quality control. So from a software perspective, and a software that runs many different types of CMMs and brands and models and things, if the GD&T is associated with the CAD model, softwares such as Verisurf can read that GD&T and create an automated inspection plan. So it's really so much as just dragging and dropping those features into the planning portion of our software called Verisurf Automate. And it automatically adds the MBD features, associated inspection balloon characteristics, tolerance values, feature control frames, and datums to the inspection plan. So really then it's just a matter of, it's not 100%, but it is a great start, and there's a little bit of cleanup and a little bit of checking you want to do. And of course you want to run a simulation, but much of this is automated. If we were talking about AI, wow. Okay. Here's an opportunity for AI to look at look at a CAD model, pull out the control frames, put them in a plan. After you've done a few programs your own, AI is learning the way you want to do it. So there's a lot of opportunity in the future. Software is going to automate CMM programming and other kind of metrology processes for sure.
Awesome. Thank you, David. So I'll go to Drew to lead off the next round of questions. Now, high-end inspection equipment can require some significant training, but what are some products that don't exactly require an extensive investment in training because there is, a pretty decent amount of turnover on the shop floor?
I think, David's already alluded to it. In those environments, the key product we see a lot is portable or manual metrology systems. So portable arms, handheld laser scanners. These are very simple tools to use. They got great approachability. Sometimes if you have a really large CMM with a 5-axis head, sometimes new operators are a little bit intimidated by it. But nobody's scared to pick up the laser scanner and shine it on the part and gather some data. So those are great tools in the toolbox that we see a lot of easy adoption with. And I think, a lot of our customers too, as I've said before, use Greg's products. And I've always been impressed with the walk-up ability and the ease of use with the Starrett line. I think there's just a lot of great tools out there in software. We have customers who use Verisurf And before they even go to class 3 days later, they're self-taught, they're writing programs. So I think the tools are there. And part of it is just eliminating the stigma that it has to be complex. You might have a challenging part to measure, but that doesn't mean it has to be hard to do, because we're all providing great tools.
Awesome. Thank you, Drew. So David, we'll go back to you with the same question. As far as, ready to use products, things that wouldn't require a whole lot of training, what kind of things are out there on the market, from Verisurf when it does come to metrology?
Mm-hmm. Yeah. So because, measurement can be very generic, whether you're using a measuring device to place something in an assembly, or a measuring device to reverse engineer something, or a measuring device to inspect something. The way we address these multiple applications in one software user experience is to have specific sort of skins and setups. So if you're doing tool building, you might select the tool building interface where the toolbars and the process workflow is more set up more to that sort of thing. Well, we also have the ability to set up the user experience based on the device type. So if you use a portable arm, then the options and icons and the process available to you are different. If you're programming a Wenzel CMM with a 5-axis head, then the options available to you are different, based on that process. So, the software can do a lot to make the user experience much easier to learn. I'm impressed with what Greg said about 1 day of training. I would say for our product, it can be learned in 1 day, but we typically do a 3-day training class. And that will typically take a new user, through whatever they're needing to do within their facility to be effective. And we can do that either at our facility or on site at the customer's facility. And we like going to the customer site because then we can really focus on their parts, their machine, and blend that into their process along with our software. So yeah, it doesn't take a lot of investment. I think almost all training costs are about the same, regardless of what company you go to. It's going to be about probably, $1,500 per user per day, something like that. Yeah. So thank you so much.
Yeah, awesome. Thank you, David. So
Yep.
Greg, we'll wrap things up with you in this round of questions. As far as at Starrett, what are some products that, don't exactly require an extensive amount of training and are easy to use for places that might have a high employee turnover?
Yeah. So that really is, excuse me, sort of our core competency when it comes to our software, is that it is really conducive to just walk up and use it. If you can get a part in the field of view in focus, you can touch on the touch screen on those features, and it's going to interpret, yep, that's a circle. We just took 177 points. Here's your form error. Here's the diameter. You touch another circle, put a relation between them. You can teach somebody to do that in 5 minutes. It's very, very intuitive in that way. What we also find is that the form factor of the machine matters a lot. And I think, Drew sort of alluded to this, that the perception of the complexity of the machine really affects your audience as far as their confidence in learning it, right? The confidence is key. It's like, you have to convince them that, yes, you can do this. It's really not as hard as you maybe think it is. When they see our gantry style machine that's got 2 cameras on, it's got a zoom lens and a field of view, and also a touch probe on it with a probe rack. At the end of the day, it's the same software that we're using on our field of view only machines. It's but when what we find is that particularly our HDV line, which looks like it's an optical comparator, right? But instead of a projection up to a screen, it's using a camera. But because people are used to that form factor in these shops, and a lot of these wind up on shop floors, they just know how to use it. They go up to it, they're comfortable using it. And we find that it's our best selling product for a reason, that anybody who has experience with an optical comparator is going to feel very, very comfortable starting with an HDV, and then oftentimes they're like, oh, so your vertical machines are the same software, just now I have a touch probe and a Z-axis. Great, we'll buy one of those too later on down the road. So that's and again, when they're programmable in your high turnover environment, you just pull up the program and it runs, right? As long as they know how to fixture the part or datum the part, it's very, very fast to get somebody actually using those machines. So yeah.
Awesome. Thank you, Greg. So we go back to David for our next round of questions. And this one's pretty open-ended, but what can proper metrology solutions add to manufacturing operations?
Yeah. So what, I mean, a manufacturing operation, the major benefit is the identification of products that are trending out of tolerance. And the sooner you can do that, the better. If they're trending out of tolerance, you have the ability to be proactive and adjust the manufacturing operation or process to trend it back in to tolerance. So you don't make bad parts. That's, to me, probably the number one is preventing a bad parts to begin with. The second thing is identifying bad parts before they continue on in the value-added process. If you have a bad part and it's not gonna make it any further, you don't want it to go any further because you're spending resources on a bad something that can't be recovered. So that's kind of the broad answer to the question. But okay, so how do you do some of these things? Well, measuring a part and adjusting offsets, using metrology techniques to best fit and align parts onto a machining situation. You get let's say you have the shovel of a skip loader, and you need to do some secondaries on this huge cast steel part. It's not like you're moving the part around on the machine to machine it, right? If you are, you're hitting it with a big sledge to hammer it into place. Well, you don't have to. You can scan the part and then align the part to the machine. So this is using advanced metrology in process to align the part before you even start machining. So there's a lot of examples of how to use metrology up front as part of the manufacturing operation, both to make sure you got a great alignment and then also to make sure you make adjustments so you don't trending out of tolerance.
Awesome. Thank you, David.
Yep.
So Greg over at Starrett, we will go to you with the same question. Once again, a lot of options here, but what can proper metrology solutions add to a manufacturing operation?
Right. Yeah. So I think, to David's point, obviously the ultimate goal is to, not be producing scrap and or sending products out to your customers or OEMs that are causing, problems. When I think about the term proper metrology, right? What's proper metrology? So I think a lot of it has to do with what is it you're going to decide to measure and how, right? So you can measure all kinds of stuff. Like I could, I could measure the reflectivity of some component internal to my machine, but I don't care about that, right? So finding the things that really impact, the critical components. What are the critical features on the critical components to what it is you're producing? And how do you plan to inspect those in an efficient way, right? So I think a lot of it is, rather than trying to measure as many things as you possibly can and get as much data as you possibly can, maybe eventually you get to that point. But, if you're starting from, very little metrology, it's like, what is the thing I can do that's going to have the biggest impact on my business? What is, what are the things that have a high hit rate as far as failure goes, identifying those parts and identifying specifically what it is about those parts that have that issue, and then coming up with a solution to eliminate that or make it reduce it substantially, right? So, and then that will drive you towards what kind of product do you need. Is it a multi-sensor system or is it a specific kind of caliper? I don't know. It's really up to that business to determine that. But obviously, you're just solving problems. Nobody wants to be living in Groundhog's Day, having the same issue with the same part for 5 years, right? So as so to me, I like to make a priority list of, okay, here's the heavy hitters. Let's start solving these and move on down the list, and then sort of build your metrology that way. If it, if I was doing it from sort of blue sky, I suppose.
Awesome. Thank you, Greg. So Drew will wrap things up in this round of questions with you. So what can proper metrology add to a manufacturing operation?
To build on what Greg and David already said, we don't, our job, our customers make money by sending good products to their customers. They don't make money by inspecting parts, right? So we are part of the process of shipping good products, but we are not the process. So our job is to provide data to manufacturing engineers, manufacturing leaders, to be able to make decisions to make more good parts faster. Really, that's all we're trying to do. We're trying to give them information and then get out of the way. We want to be as transparent as possible to the end product getting shipped out the door. And I think what my co-panelists have said speaks to that. So nothing else to say.
Awesome. Thank you, Drew. So we'll go back to Greg at Starrett with our next question as we ask about the calibration process. So how has the process changed in recent years? Has it sped up? Is it required less often? Like, what does a modern calibration process look like in metrology?
Well, I can really only speak to our systems here. However, obviously the addition of CNC functionality makes a huge difference when it comes to calibration, right? You can put your standard down, pull up a program that's pre-written, hit play, and it will run through that and give you results. So, for us, there's sort of there's multiple pieces, but, you have the optical calibrations, then you have the stage error mapping, and then the validation of the stage performance. And all of those can be automated. Typically what I recommend our customers consider doing is to check the optical calibration. So check the validity of the optical, performance on a regular basis, like once a month, something like that. And also the stage performance using just a linear standard in our case, generally speaking. And in both of those cases, and in fact, oftentimes as part of the training, we will write those if they bought one of those from us, we will write those programs for them and say, hey, once a month, pull this program up, put your standard down in all these different positions on the stage and just run it. And there are already pre-tolerance. You'll know if it's in or out. And then we'll even tell them, if they're a user at a level that they're comfortable doing this, if it's a linear error that they do find it slightly out somewhere, you can adjust that error map very quickly. So you can go through a validation process in about, 20 minutes, and then adjust the error map and get that thing measuring perfect very quickly.
Awesome. Thank you, Greg. So Drew, will go to you with the same question. What is kind of the modern calibration process when it comes to metrology? Has it sped up? Is it required less often? Kind of what is different in the past few years?
Well, I think there's two components to that from what we typically see. There's the regular calibration and maintenance of the machine itself, where you want to have a certified technician come in with gauge blocks, Kobo bars, things like that, and verify that the ultimate accuracy and uncertainty of the machine is still within manufacturer specifications. Day to day, though, there's been a tremendous advancement in the calibration of the probes when we talk about a tactile CMM. And using tools like the modern 5-axis probe systems give you so much capability to really reduce the amount of time you spend every day, every week, however your quality policy dictates, calibrating those probes to ensure that you're measuring good parts. The softwares that we have available, tools that are in Verisurf, make it very easy to automate this process as well. So you can launch a program that will take all the styli you're going to use that day out of the rack and calibrate them all while you're, not even there. It'll run lights out. So we try to give, it's non-value added time per se, right? It's important and we all have to do it, but it's not helping you get parts out the door. So as much as we can minimize the impact on your productivity, that's what we try to do.
Awesome. Thank you, Drew. So David, we'll wrap things up with you in this round. When it does come to the modern calibration process, how has it changed in recent years? How often is it required? How has it sped up?
Yeah, well, First of all, there's a lot of amazing calibration standards and gauges, length standards, ring gauges, lots of things that are out there that, traceable all the way to NIST or whatever your national standard might be. And a lot of varying sort of length standards and things depending on the type of device. Laser trackers have some amazing length standards. One of the most significant things that I've seen in particularly speeding up are some of these 5-axis technologies. And I would have to say that what I've seen from Renishaw and inferred calibration techniques for their Revo and their PH20 that determines the head orientation and probe position in a single operation and then allows subsequent measurement of any head angle. It with just a few touches, it can infer all of the different probe angles. And anyone who's run a programmable CMM knows that it can take a significant amount of time to calibrate the machine with the various probe angles before you even start to measure. And depending on your process, some state that they must do probe calibration before running every part. And so that if that's the case, if you're real high precision in operation, this could double the amount of time that it takes. And so there's been a lot of nifty things going on from a programmable CMM perspective. As far as automating calibration, Verisurf software can automate repeatable calibration process, with portable CMMs as well. So the calibration can be part of the inspection plan so that the calibration is done, then you do your alignment, then you do your inspection and do your report. And the calibration is included in the report then. So it's changed a lot, new technologies, and it's getting faster and faster.
Awesome. Thank you, David. So Drew, will go to you with the next question. How do you know if a shop floor metrology system is right for your application?
That's a great question. When we see this being one of the most common topics we discuss now with customers is how do we move the inspection process closer to the manufacturing process? And, there's a lot of variables that come into play. But the number one thing we want to understand is how do you want to integrate that? What are you going to gain by it? If you're just trying to shrink footprint, that's one thing. If you're trying to, give manufacturing autonomy over the inspection process and make it part of the manufacturing process, then that adds another layer to it. But at the end of the day, how clean is your shop? How good is the environment? And then that dictates the type of machine we would offer and recommend to put on your floor. We have a lot of shop hardened machines that we can put out there that will live in a very aggressive environment. But we also have customers who have phenomenal manufacturing floors where there's no dust, there's no oil, there's no dirt. The temperature is plus or minus a degree. And we put our lab machines out there. So it really depends on the environment and what you're trying to accomplish. The last layer of that then is, are you going to automate it? A lot of people want to put these machines nearline now or inline and robot load or semi-manual load. And so we try to adapt the solution to that. We can work with their integrators. We can offer our own automation packages, and we can get these things as seamless into the process as they want them to be.
Awesome. Thank you, Drew. So David, we'll go back to you with the same question. Over at Verisurf, how do you know if a shop floor metrology system is right for your application?
When you need to be sure the part is good before moving on to the next process. Basically, it kind of goes back to, how do you put measurement in the manufacturing operation? I think if you're going to, environmental conditions also play a great part in this. For instance, Venzel has some products that are, I guess you could say, shop floor hardened. They do different techniques with the machines. There are machines that have no air bearings; they use mechanical bearings instead. They have extra protection for the sliding surfaces and other surfaces that need to stay clean. Other shop floor things that are kind of nice to have if you're going to put them in line. A lot of it has to do with the ability of whether or not you have compressed air in some cases. Also shop floor power. Sometimes you don't have access to two-phase or larger, power applications. So all of these play into account about your ability to, incorporate measurement process, right there next to the point of manufacture.
Awesome. Thank you, David. So Greg over at Starrett, we'll wrap up this round with you. How do you know if a shop floor application, if shop floor metrology system is right for your application?
Right. So in a lot of cases, we'll actually sell, particularly our HDV line into a shop floor environment, and not necessarily for a specific application, but just sort of for the walk-up metrology general use. Like they're saying, if they need to check something to make sure it's right before you move on to the next process, that system in particular is very conducive to that. But when it comes to, are you going to integrate this on and be checking every part? Again, they've already said this, but the environment is probably the number one most important thing to consider, right? We had one case where somebody put one of our systems next to this huge stamping machine. I mean, it was like out of Jurassic Park, right? This thing is, you got the water jiggling every time this thing goes, and they're like, man, we just can't get repeatability on these. I'm like, yeah, I bet you can. So, in that case, we wound up finding an isolation table for them, which seemed to solve their issue. But, it's really like, if you're going to put it in a shop floor, you have to sort of level set your expectation of, okay, what's our environment? How stable can we keep this metrology system, and what are our expectations as far as the accuracy goes, right? So, but generally speaking, our accuracy is so much better than what it is they're requiring. If they're measuring plus or minus 5 thou, and our maximum permissible error on our machines like 4 microns over the whole length of it, they're probably going to be fine, right? So their GR&R is going to be fine for that. It's really is managing expectations when it comes to shop floor stuff is important. And I think that, all that said, and also calibrating it in the environment where it's going to be. If they, for whatever reason, have their doors open that day and the rest of the year they don't, don't calibrate it that way, right? Like you want to try as much as possible to set up that machine in the environment and the way that environment's going to be, and make it clear to them, hey, if you can put this in the back corner away from your big bay door versus out next to that door, please do that, and move it away from the stamping machine while you're at it, right? So that's those are the kind of, it's really more logistical considerations rather than like, is it really appropriate for the part or not, right? So yeah, that's what I would say are the major things I think about in that scenario.
Awesome. Thank you, Greg. We're actually going to stay with you for our next question. So what role do vision systems play in automating inspection in manufacturing processes?
Yeah, so in my mind, there's sort of two families when it comes to machine vision of inspection, right? Mostly what we've been talking about today is the sort of quantitative side of metrology and inspection, where you're doing dimensional metrology, you're checking feature positions and dimensions and things like that, right? I think, and probably the more common type of vision that you see when it comes to automation and inspection is the qualitative type of inspection, where rather than measuring features in their dimensions, you're counting pixels to see, does this blister pack of pills have a pill in every single one of these, right? Is the label on upside down? Is the hot dog the right color coming down the line, or whatever it may be? So we often have people come up to us and ask us if we can solve those kind of problems, and it's not what we do, right? Generally speaking. There's also, online versus offline when it comes to vision inspection, right? There's, you got guys like Cognex who most of their stuff is designed to be inline, right? Whereas the vast majority of our customers are offline, doing inspection in a lab. So Those are sort of, and then you have field of view only machines, sort of like, one of our KMRs, or like a Keyence kind of a machine, or a machine with a stage where it's really more of a CMM, that rather than a touch probe, it's using a camera as the probing tool. So those are sort of the role. So vision is a weird one in the sense that, you hear that term a lot, but it's very, very different depending on how it's applied, and sort of just understanding those different categories will help you sort of lead you in the right direction as far as what it is you may need for your solution.
Awesome. Thank you, Greg. So Drew, I'll go to you, and this might be a little jumbled, but since we are running out of time, would you like to answer a question about vision systems? We also have non-destructive testing that we're hoping to get to, and also fixturing or inline metrology. Is there any one of those four that you would like to touch on?
Let me take non-destructive, if I may.
Okay, so what
For
are the
1,000,
latest
Alex.
developments in non-destructive testing?
So for us, what we see, we have a line of computer tomography systems, so industrial CTs, where we can put the part inside, spin it around, X-ray it, and give you a point cloud of data inside and out. This lets us do non-destructive testing of mixed materials, maybe assembled components. Maybe you have an electronic box that is sealed that has somehow failed prototype testing, things like that. We can take that and look inside and see what the failures are before you start removing things and maybe lose a piece of evidence of what's gone on. These systems can also do full metrology, so it scales up to that level as well when you start to need to PPAP parts and things like that. So for us, that's really the cutting edge of what can we stick inside a CT? How can we look inside it and then give you feedback on maybe your metallurgy, your molding process, your assembly process, whatever it may be. We can give you very crisp, high-res pictures, large data sets, and complete data sets too. So anything that fits in the field of view, you have a point cloud of for future questions. You may not need to ask right now, but you might 6 months from now go, hey, what if we did this to the process? How would that change things? We can look back and compare new parts to that old data.
Awesome.
So that's really where we are.
Awesome. Thank you, Drew. So David, we'll go to you, and I'll kind of ask the same question. Would you like to answer the question about vision systems? We also were going to talk non-destructive testing, fixturing, or inline metrology.
Yeah, I'll go with the inline metrology.
Okay. So what are the benefits of inline metrology?
Right. So, I'm going to talk a bit about portable CMMs in this application, because inline metrology is where they're very, very useful. And let's just start with, like I said, taking parts and aligning them to the machine. Of course, many CNC machines, they have machine tool probing for alignments, but sometimes there's more complicated, complex profiles and things that are difficult to probe. Or these big machines don't have probing systems. It's going to require a laser tracker or a portable CMM arm to align it to the machine. And so what's the benefit of using metrology to align a part to machine? Well, you can't machine it unless you know where the program is and associated to the part. So if the part's super heavy, or if the part is really big, it's difficult to get that alignment without banging it around with a sledgehammer, right? So if you can quickly scan some key features in some areas, or even probe some areas, you can best fit and you can align the part to the CNC machine and adjust the alignment and move your code to wherever the part's positioned on the machine. So alignment is a major metrology application for measurement in the manufacturing process. The other thing is often you want to check a part quickly without taking the part off of a machine or out of a machine. Yep. And so if you can do that, you can maintain your setup. And if you found that your finishing pass isn't there and you're still off and you still have some material to remove, you can do that. If you're getting too close and you might be getting too much material taken away, you got a problem, and you got to avoid gouging the part or taking too much material, because then now you really upset people. You're welding material back into place and trying to get remachining and so forth. So inspection on the machine with portable CMMs like an arm or a laser tracker, depending on the size of the part, are super, super great applications for metrology. Yeah, quick checks for offsets, all these sorts of things are benefits of inline metrology.
Awesome. Thank you, David. So
Yep.
Greg over at Starrett, I will give you the final chance to not rebuttal because it's not a debate, but would you to have anything to say about non-destructive testing or inline metrology before we wrap up today?
Yeah, you know, obviously non-destructive testing is near and dear to our hearts, being even in our case mostly non-contact, right? You know, and that's something that let's see. So the latest development is non-destructive testing. Yeah. So I would say, you know, one thing that I'm noticing is it's always been difficult. So one of the non-contact things, and so I'll talk about non-contact rather than non-destructive, because basically everything we do is non-destructive for the most part. But when it comes to non-contact, you know, one of the challenges is that if you can't get a good edge on something with the vision system, you know, maybe you want to use a laser, right? The problems that we're finding with laser, what we've had historically with lasers, is that depending on the material that you're measuring, it can give you wildly different results. So you sort of have to calibrate that laser to the material that you're using. However, there are now white light sensors that appear, and we don't have one of these. This is one of the things I want to use, but they appear to you know, basically get around that problem. And I mean, there are people who are measuring the surface of like water with these things, and you know, completely transparent surfaces. And you know, I think that that's probably, when it comes to non-contact stuff, the best probing technology that there is, at least from what I'm reading about. You know, in cases where you can't get a good high contrast edge to measure on. So yeah, I'm very interested in you know, attempting to integrate that here at some point. No promises though. We don't have one. It's not available. Don't ask for it. But that's one of those things we would like to research a little bit more. And you know, I would recommend it for anybody who has that specific scenario.
Awesome. Thank you, Greg. So I am sorry to those in the audience who have asked questions. We have run out of time today, but each of the panelists will get those sent to them. And if they would like to, they can answer them at their leisure and send you those answers. But once again, I want to thank today's sponsors with Starrett and Wenzel, and a very special thanks to Verisurf Software. And also I wanted to thank David, Greg, and Drew. Thank you, gentlemen, for giving me some time today, and I hope you guys have a very happy holiday.
Thanks, Jake.
Thank you.
Thanks.
Thank you.